Let us start with these two terms, 0 polynomial and 0 of the polynomial. Sometimes the students are counting these two are same. For your kind information, these are two different things. 0 polynomial, I said ki when it is a single 0 written, that is called a 0 polynomial, and degree of this is undefined. This is 0 polynomial. And if you speak about the 0 of the polynomial, suppose I am giving you the example is equal to x square minus 4. Suppose this is there. Any polynomial px is given equal to x square minus 4. If I find p2 here, suppose p2, that is I need to replace x by 2. So what happens? 2 square minus 4 and this become 4 minus 4 is equal to 0. Means when the polynomial is given in any variable and I replace that variable by a particular value which makes that is equal to 0 is called the 0 of the polynomial. As here what I did, I have written px is equal to x square minus 4. So that is given in terms of x. Now I replaced x by 2. I said let us find p2, that means I replaced x by 2. And what happened finally? That becomes is equal to 0. So that value of x2 will be the 0 of this polynomial. So whenever you will be asked to find the 0 of the polynomial, means you have to check a particular value of that variable in which the polynomial is given to you is makes that polynomial equal to 0. Then you have to write yes, this is the 0. If not, then it is not the 0 of the polynomial. And remember, if the degree is 2, so maximum 2 zeros are possible. Maximum 2 zeros are possible. If degree is 3, so 3 zeros are possible. If degree is 4 and so on, 4 zeros are possible. So if 2 may be or may not be, but maximum 2, remember this. So that depends upon the power. Power is 1, 1 zero is possible, 2, 2 zeros, 3, 3 zeros, 4, 4 zeros, and so on. So purpose was only to make you people understand what do you mean by 0 of the polynomial and what is a 0 polynomial. So 0 polynomial is when you are writing the single term 0 and whether that is a polynomial or not, yes, of course that is a polynomial, but that is called a 0 polynomial, degree of which is not defined. And constant polynomial, any constant number I said like 2, 7, minus 7, all these are the polynomials. These are called constant polynomials, always carrying degree 1. But 0 of the polynomial, in which variable the polynomial is given, if that variable makes that expression is equal to 0 is called the 0 of the polynomial. So whatever I discussed with you beforehand, all the definitions, what is a polynomial, what is the degree of a polynomial, what is the standard polynomial, types of polynomials, and now 0 polynomial and 0 of the polynomial. All these are the terms which you need to use in your exercises. So if you pick your exercise 2.1, so today I will be sharing, like in one question it is asked that find p0 comma your p1 and then p2. So any one part I will be taking, like second I am taking when it is given px is equal to what? X minus 1 into x plus 1. So first of all you solve it. X minus 1 into x plus 1 can be written as x square minus 1. A minus b into a plus b is equal to a square minus b square. So then you find turn wise, p0 means 0 square minus 1 is equal to minus 1. Then it is p1. So p1 is equal to what? 1 square minus 1, that is 1 minus 1 is equal to 0. And finally p2, so that is equal to what? 2 square minus 1, 4 minus 1 will be equal to 3. So in that way you can find the value of p0, p1, p2. But try to understand, even you are saying p0 means you have to replace the variable by 0. If it is 1, so you need to replace the x by 1 in both the sides. When it is 2, so then you have to replace the variable by 2 and keep on checking the answer. So the next question, verify whether the following are zeros of the polynomial against them. So this question I discussed right now with you. So you have to check randomly. I will pick few parts. Suppose I am taking your part number 3. Part number 3 somewhere of your this question is px is equal to x square minus 1, and zeros you need to check is x is equal to 1 comma minus 1. So first you check p1. So that is 1 square minus 1, 1 minus 1 is equal to 0. So answer is yes, x is equal to 1 is the 0. So this is the right procedure to write your answer. Then you go for p minus 1. Again what happens? Minus 1, I know negative square is again positive, and again this makes 0. So answer write simultaneously. Yes, x is equal to minus 1 is the 0. All the times this is not going to happen ki both can be the 0, but I said ki maximum 2 zeros can be there for degree 2. So where both are making the result is equal to 0. So that's why x is equal to 1 as well as x is equal to minus 1 are the zeros of this polynomial. Now suppose I am taking fifth part. So in fifth part you see it is given that px is equal to x square. Px is equal to x square, and x you need to replace by 0 only. So p0, so 0 square, again this will be 0. So yes, x is equal to 0 is the 0 of this polynomial. Then sixth part you see immediately, here it is px is equal to what? Lx plus mx, Lx plus mx, and what you have to check is x is equal to minus m upon L, minus m upon L. So let us replace x by minus m upon L. What happens? L into minus m upon L plus m into minus m upon L. So p minus m upon L becomes L, I can cancel. Here it is minus L upon x minus m into x minus m upon L. P minus m upon L, this is minus m, plus minus is minus m square upon L, which is not going to be equal to 0. So therefore x is equal to minus m upon L is not the 0 of this polynomial. So make a note of that. If the result is coming equal to 0, then it is 0, otherwise not. Then another part, suppose I'm taking the seventh part where it is in third form given to you. So what is the seventh part here? Seventh part is you need to check px is equal to 3x square minus 1, where you need to check x for 1 is minus 1 upon root 3 and another for 2 upon root 3. So let us see what happens here. When here this is minus 1 upon root 3. So 3 into minus 1 upon root 3 square minus 1. So p minus 1 upon root 3 is equal to 3. Minus square is always 1 and under root 3 square is 3 minus 1. Minus square is always plus, 1 square is 1, under root 3 square is always 3. 3 ones are and 3 ones are. So p minus 1 upon root 3 comes 1 minus 1, which is equal to 0. So answer is yes, minus 1 upon root 3 is the 0 of this polynomial. Second is 2 upon root 3. So now p into 2 upon root 3 is equal to 3. This is 2 upon root 3 square minus 1. What happens here? 3. 2 square is 4, under root 3 square is 3, and you do this cancellation. 4 minus 1, which is not equal to 0, so therefore no. 2 upon root 3 is not the 0. Is not the 0. So in that way you have to express your answer. So this is the question. In all the parts you keep on practicing and check whether the terms are giving you those particular terms, making that expression is equal to 0. If yes, then write your answer with yes. If no, then write your answer with no very clearly at last. Last question of this exercise. Now you need to find the 0 of the polynomial. So like first part is px is equal to 2x plus 5. Question is find the 0. So find the 0 of this polynomial. Means I need to find out a particular value of this variable x in which the polynomial is given, which make this expression is equal to 0. For that, what you can do is, whatever the expression is given to you, put that is equal to 0 in your rough margin. And from here you see what is the value of x you are getting. That is coming somewhere here is minus 5 upon 2. So what I can check is p minus 5 upon 2. 2 into minus 5 upon 2 plus 5. You just cancel it up and see what happens. Is equal to 0. So therefore x is equal to minus 5 upon 2 is the 0 of this polynomial. So that I need to find. So similarly in other parts also you can try. Like suppose I am taking px is equal to 3x. If px is equal to 3x, again if I put 3x is equal to 0, so what is x is equal to 0 upon 3? That means 0. So I will find 0 is equal to 3 into 0, and that makes is equal to 0. So means x is equal to 0, 0. X I have replaced by 0. So which is the 0 of this polynomial? So 0 is the 0 of this polynomial. That you can check in your rough margin. And suppose ki one more part I am taking, like fifth part, px is equal to cx plus d. Px, fifth part, this is px is equal to cx plus d. So in your rough margin, again you go for this. Cx plus d is equal to 0 means cx is equal to minus d means x is equal to what? Minus d upon c. Get the value of, make the subject variable, that is x, because polynomial is given in terms of x. So x I need to replace there minus d upon c. And I have to check whether this minus d upon c will make this is equal to 0. Only then I can call that is the 0. Let us see. So p minus d upon c, c into minus d upon c plus d. C you can cancel and you are left with minus d plus d, which you can cancel, and again make this is equal to 0. So I will write that minus d upon c is the 0 of this polynomial. So from section A question point of view and section B question point of view, this is very important to find what is the 0 of the polynomial and how to find the 0 of the polynomial. So this whole exercise is based upon these basic concepts only, what we learned. So you please finish this exercise, and next part is your application of your remainder theorem or factor theorem. So tomorrow I will come to you with the proof of your remainder theorem, though proof is not there in your syllabus, but I will share so that you can understand how to use this remainder theorem here in this chapter of polynomial followed by the factor theorem. Thank you.